All right, the last section that you guys need to know right now is 6.5, solving radical equations. So if you look at this number one is just the problem. This is my radical equation. Why is it a radical equation? Because it has a radical in it. So in order to solve a radical equation, we want to get rid of the radical. So the first thing we want to do is try to get rid of the square root sign. So if you remember, to get rid of an x squared in a problem, for example, if I had that, we would take the square root. So these undo each other. So if I want to get rid of this, I need to square it. But whatever I do to one side, I do to the other. So now I square it. So I get 2x minus 1 equals 3 squared. Be careful, let's not take 3 times 2, but 3 times 3, which is 9. And then we want to add 1 and get 2x equals 10 and x equals 5. Okay, the only thing you do want to do with the problem, as if you would any equation, is plug it back in. Is 2 times 5 minus 1 under the square root equal to 3? So 10 minus 1 is 9. Is the square root of 9 equal to 3? Check. The only other thing you want to do when you start the problem is to make sure that you don't have anything in front of the radical or added or subtracted to the radical. When you do these problems, you want to make sure the only thing you're doing is squaring a single radical on that side. So let's look at our next example. Okay, in this problem, it's a cube root of x plus 4 equals 4. So now the thing is, instead of a square root, it's a cube root. So what do I need to do? I need to cube both sides. So if I cube one side, I cube the other side. Okay, and so this cubes will undo each other, leaving me with x plus 4. And you need to realize this is 4 times 4 times 4. There's also a caret button above the dividing sign on your calculator, and you can put 4 caret 3 in your calculator, which if you do that, 64. So this equals 64, and x plus 4, and x equals 60. Again, it cannot hurt to take the cube root of 60 plus 4, which is the cube root of 64. Okay, and we can always break that down. 16 and 3. 16 and 4, 16 and 4, and 4 and 4. So perfect. So we know that answer is 4. So that checks out. Okay, so let's look at 2 more that are similar. Okay, so here's what I'm talking about. Here is your radical. Okay, and I don't want to do any squaring until I get that radical by itself. So first thing, this 2 here is positive. It's being added, so I'm going to subtract this before I start. Now I have 2 root x equals 6. Now, you have an option here. I can take this and square it, but a lot of people are going to mess that up, and they're not going to remember to square the 2. So the way I try to do it is you can get this radical all by itself by dividing by 2 before you start. So get just the radical isolated by itself before you decide to do the opposite operation. So here I square root, I square it, and x equals 9. Again, if I go back up here and check it, it's 2 plus 2 times the square root of 9 is 3. Does that equal 8? Check. So we want to get, you can check your answers for every one of these. So this one, same exact thing. Here is my radical, or my cube root in this case. So I want to get rid of everything else. So first I have to get rid of this because it's by itself. So now the cube root of x equals 4. At this point, I'm going to divide. So I divide by 2, and I get the cube root of x equals 2. And now I have the radical isolated by itself. And now I can do the opposite operation, which would be to cube it. And x equals, remember, it's 2 times 2 times 2, which is 8. If I go back, 2 times the cube root of 8 is 2, minus 1, 4 minus 1 is 3. I know that's my right answer. So if you would, let's look at this. So this one, it's got two things under the radical, but if you look at the problem, this is the only thing on this side of the equal sign. So at this point, I can take this and cube it. I can take this and cube it. So when I do this, I will get x squared plus 2x and 2 times 2 times 2, which is 8. Now, the only issue is this brings me to a quadratic because I have x squared and x. Whenever I have a quadratic, I set it equal to 0, so I minus that 8 over. And at this point, if you could remember factoring, that would probably be your easiest. If not, you can always run the quadratic formula, which is the opposite of b, plus minus square root b squared minus 4ac over 2a. We can always run the quadratic formula, but this one factors very easily. Remember, factors of 8. That will get me 2. And so it's going to be plus 4 and minus 2 will get me negative 8 and a positive 2. X plus 4 equals 0 and x minus 2 equals 0. X equals negative 4 and positive 2. Now we come out with two answers. This is where it's very, very important to try both your answers because sometimes they'll work and sometimes they won't. So over here, I'm going to take the cube root of negative 4 squared plus 2 times negative 4. That's going to give me the cube root of 16 minus 8. That's going to give me the cube root of 8, which is 2. So it checks. Then if I put a 2 in here, I'm going to get 4 plus 4, right? Because 2 times 2, and the cube root of 8. So in this case, both answers check. So that is my answer. Okay. Radicals on both sides, that's okay. In the problems we're going to be doing, it most likely will be just a radical and a radical isolated. And so at this point, I simply square both sides and it would get rid of the radical. So 4r minus 1 equals 3r, negative 1 equals minus 4, negative 1r, and r equals 1. Okay? So easy. And this last one is definitely more of a challenge problem, definitely more bonus style for you guys. So let's look at this. I need this radical to be by itself. So the first thing I'm going to do is move this over. So I get x minus 5 equals, and now I get x minus 7, which is a little different. So as long as my radical is isolated by itself, I can start to get rid of it. But when I do that, I have to put the x minus 7 into parentheses and square it. So this side actually is very easy. It's this side that becomes a little harder. X minus 7 is not x squared plus 49 or minus 49. It's x minus 7, which means we have to do what? FOIL. So x minus 5, x squared minus 7x plus 49. So now I get x minus 5, I get x squared minus 14x plus 49. Since I have an x squared and x in the problem, it's going to be a quadratic. Sorry. So at this point, I'm going to subtract 5 and add 5, subtract x and add 5. So my quadratic becomes x squared minus 15x plus 54. Okay. So now list of 54, and I think 9 and 6 are on that list. You could always run the quadratic formula again if you wanted to, but here it's going to be x minus 9 and x minus 6 will both get me positive 54 negative, and then I get x equals 9 and x equals 6. and now you have to check it. 9, so if I do 9 minus 5, it's 4 plus 7. The square root is 2 plus 7. Does that equal 9? Check. When I put in 6, it's the square root of 1 plus 7. Does it equal 6? 1 plus 7 does not equal 6. So 6 is not my answer. Only 9. Okay. So, a lot of problems. You can go back and reference any of them. And hopefully you tried them on your own before going through the whole video and hit pause. All right, thanks.